Hi, this is Dr. Remenacker. In this particular video, we're going to look at how are ticket prices set for various events. The event could be something like a large concert, or it could be something like a local community project like the one that's being addressed here. As with other optimization problems, the 6 steps that we have listed here at the start are things that you want to keep in mind. Keep in mind as well that probably the most challenging part of the problem is developing the mathematical model of the situation. Okay, so with that in mind, let's take a look at the problem we're going to solve. Okay, so the college holds a fundraiser each year to help low-income residents. This could be, I don't know, a fall fling, a spring um, fling, something or other, some kind of an event that's fun and people come to and like a carnival. The price per ticket and the number of tickets sold from previous years is shown in the table below. That's that table right there. Based on past events, each person is expected to spend about $8 on food, and expenses are estimated to be about $1,450 for tents and entertainment, and the food's projected to cost about $450 a person. How much should tickets sell for to maximize the profit? How many people are expected, and what's the projected profit for the event? Important questions to answer while you're planning to even decide if it's worth it. If the whole thing is going to take 2 months to set up and you're going to make $50 profit, probably not worth doing in its present situation. You may want to change the format or something like that and try something else, but 2 months work for $50 is not worth pursuing. Okay, so what are we going to do? The very first thing you must be very careful to do is when you're given data, don't assume that the first column is X and the second column is Y. It might be, it might not be. Remember that X is the value that controls or dictates the other value. Do the ticket prices control the number of tickets sold, or does the number of tickets sold determine the ticket price? Well, you know as well as I do that the price of something determines how much of it you're going to buy. So the thing that is controlling the number of tickets sold is the ticket price. The ticket price is X. The number of tickets sold is Y. I'm going to label that right now. And this reminds me later on, hey, X is the ticket price. Y is the number of tickets sold. Okay, so where do we go from here? Well, first recall that profit equals revenue minus cost, where revenue is equal to the number sold times the price. The price in this case is going to be X. The number sold is dependent on X. Now, in order to get an equation for the number sold, we are going to need to do regression analysis using the data that we have. Okay, so the data that we have is something that we're going to want to enter into the calculator. To do that, you press Stat, then you go to Edit. Once you're at Edit, you want to, in List 1, enter the various ticket prices, the 10, the 15, 20, 25. Then in List 2, we're going to put the number of tickets sold. From here, we need to set the window so that we can look at the shape of the data. The X values are my ticket prices. Notice I've run it from 0 to 30 by 5, so I have some space on each side. The Y values are the number of tickets sold. I've run this from 0 to 225. Okay, and this allows me to have some space beyond the number sold at 200. And I'm going to check my Y values. Okay, I've got something in there. So for right now, I'm going to turn that off. I'm going to press Enter, and that's off. And now I also check and I see the plot 1 is on. So I'm just going to press my graph, and there we go. If you look at this data, I hope you realize that this is not a straight line. This is part of a curve, and you can see that it's leveling out. There are a couple of different functions that we could use to model this. One of those being an exponential function, the second being a logarithmic function. Either of those is going to give us this shape. I'm going to go to Stat, move over to the second option in the toolbar up at the top, Calculate, and I'm going to do a linear regression, or not a linear, a logarithmic regression, ln. So I'm just going to press Enter. Okay, my X list is list 1, my Y list is list 2. I want to store this so I don't have to copy it down, so I'm going to go to Variables, come over to Y variables. It is a function, not a parametric equation, and I'm going to ask that it be stored in Y1. Now, I'm going to press Y equals and clear out whatever's in Y1. Then I'm going to quit, and it killed my stat. Okay, so I'm going to come, so you got to be careful to clear your Y value before you set this up. It's not the end of the world if you have to go through it again. Okay, my Y variables, function, Y1. Then I'm going to come down and calculate this. Okay, so it gives me this particular equation. I take and I copy this equation down here. It's already in the calculator too, but I'm going to copy it down. And by being already in the calculator in the Y equals, see it, it's there. I'm going to graph this against the data and see how well it fits. And it fits reasonably well. So I'm going to go with this. So what I've done now is I have copied down for my revenue the number of tickets sold, and remember that's the Y value, which is this equation that we just computed, times the price. I can work a little further on cleaning up my revenue function by distributing the X, which is going to give us a 415.599X minus 97.762X times the natural log of X. So there's my revenue. The next thing that I want to do is to develop an equation for the cost. There are several elements that come into play on cost. One of those is the $1,450 that you have to pay for entertainment and the tents and things. That's something you're paying whether one person or 10 million people show up. Okay, food's projected to be about $4.50 a person, so it's going to be plus $4.50 per person. So there is my cost function. From here, I want to develop a profit function, and remember that the profit is your revenue. Well, the revenue is going to be my 415.599x minus the 97.762x natural log of x. From that, I'm going to subtract my cost function. That's this 1450 plus 4.5x. I need to distribute the subtraction over each of the elements in the cost function. And combining like terms, notice I have a 415x minus 4.5x. When I do that arithmetic, I wind up with 411.099x. We're going to have minus the 97.762x natural log x minus the 1450. Okay, when we go to optimize this, in this case it's profit, we want to maximize it. The first thing we need to do is to compute the derivative. Well, the derivative of this is going to be this 411.099 minus, notice this is a product rule. Wow, it's a good thing we've been working on our derivatives. Okay, it's the derivative of the first factor, so it's going to be the 97.762 times the natural log of x plus the first factor, which is a 97.762x, times the derivative of the second factor, well, that's natural log of x. The derivative of the minus 1450 is just 0. Okay, so from here then, I have, cleaning things up, I'm going to have a 411.099. Distributing the subtraction, I'm going to have this 97.762 natural log of x minus, because I'm distributing the subtraction. Okay, I'm going to have, notice, I have an x times a 1 over x. Those are going to cancel. Well, that's great news. So it's going to be minus 77.762. Okay, the next thing I want to do then is to combine like terms. That means I'm going to take the 411 minus the 97.762. So I'm just going to do my 411.099 minus 97.762 equals. And this gives me a new equation. We have this 313.337 minus the 97.762 natural log of x. I want to set this equal to 0 and solve it. It's a good thing we've worked on e to the x and natural log x, because here it is and we need to solve it. Okay, with this set equal to 0, we have this 313.337 equals, and I'm moving this 97.762 natural log of x to the right-hand side. When I take the 313.337 divided by the 97.762, that leaves me with 3.205 equals, saving some space there, natural log of x. To cancel out natural log, the inverse is e, so I'm going to apply e to each side, and this gives me then a final value of x equal to e raised to 3.205, which looks like about 24.655. Okay, so what does x equal to 24.655 mean? Well, recall that x is our ticket price. Now, realistically, selling tickets for $24.66 a piece is a little weird. So what you would very likely do is set this to $24.50, or you might just want to set to $24 or $25. But let's keep it fairly close and say $24.50 so that it's not horrible to make change for. What we first want to do is to verify that this is a maximum. To verify that we have a maximum, what we're going to do is we're going to take the first derivative, which is up here. There we go. And I'm going to circle it. It's this line right here that we set equal to 0. And I'm guessing that the easier way would be to go ahead and take the first derivative. Well, actually looking at it, I'm going to do the second derivative, because the second derivative of this is really pretty straightforward. So the second derivative, remember, we're working with this line right here. Okay. When we take the derivative of this part, it's 0. Then it's going to be minus 97.762 times the derivative of the natural log. Well, that's just over x. We're basically done. When I put the x value in, it's going to wind up a negative in the numerator, a positive in the denominator, less than 0. If it's less than 0, that means concave down. which means that we have a max point. So it's just that quick to verify that we truly do have a maximum at this price. Okay, so what we're going to do, it's not quite perfect, but it's real close to the maximum, is we're going to set the ticket price at $24.50. Okay, the number of tickets sold, which is the same as the number of people. The number of people will be, we have to figure this out. To get the number of people, I'm going to use x equals 24.5, but I'm going to have to come up here a ways. Here we go. The number of people is the number of tickets sold. That's this value right here. So I'm going to go over to the calculator, turn that on, go to y equals, and notice we have the 415, and I'm just moving over on this y1 to let you see that what we have here already is the y equals. So I can go to the table, I'm going to go second table, and I'm going to put in 24.5. Enter. Okay, so this is going to give me 102.89. You can't have 0.89 of a person. That just sounds really painful. So what I'm going to guess is the number of people will be perhaps 102 or 103. This is not right down to the exact number, especially when you have 102.89. Okay, so a ticket one way or another, it's going to be right around there. I usually like to project on the safe side. So number of people coming, about 102. Number of tickets sold is going to be 2450. What else do we need to do? Well, how many can be expected? Got that. What is the projected profit? Now, to get the profit, you got to be careful. The profit is this value right here, now circled in yellow. And remember, X is the ticket price. So when I go to plug this in on my calculator, I'm going to do second quit. Okay, so when I put the equation in for the profit with the ticket price of $24.50, I'm going to sell about 102 of them. You can see here that we wind up with a profit of, this is profit, this is after bills are paid. So you have a profit of $960.56. That is the process of going through and determining what kind of a price to charge for a ticket to some type of an event to maximize the profit.